13 is on direct and inverse variation. This is basically solving for a variable in a direct way and an inverse way. And so I'm going to describe both. For instance, if we said that, suppose every classroom of a particular school, there were twice as many boys as girls, we would say the boys would equal 2 times the girls. This is a direct variation. And so the 2 is a constant and the boys and the girls are the variables. And so if there was another school, and in the other school, let's say that there are 3 times as many boys as girls, then we would change to be 3 times the girls would equal the boys. Now, I'm going straight from the book, so if you get confused on this, you can go back and read this yourself. In this equation, in the first school, we had the variables, boys and girls, with B and G, and the constant was the number 2. The second scenario was boys and girls were B and G again. Those were the variables, and the constant was a 3. So therefore, they use the letter K for constant. And so we're going to transfer this to different types of time, distance, pressure, weight, volume type problems, and it will tell you exactly how to write it based on the wording. So at the bottom of that page, for instance, the weight of a substance varies directly. That means we're going to set it up like this. Varies directly as the volume of the substance. And so read it in order. The weight of a subject, weight is first, varies directly with the volume of the substance. And so it says it in this order: weight, varies directly, volume. Those are your key words to learn how to set up a problem. Let's do a different one. So let's say it said the mass of a substance varies directly as the volume of the substance. The mass of a substance varies directly of the volume. Again, you just read it in order. Varies directly means you write it in this form. Mass first, varies directly with the volume. This is your constant right here. Then they will give you, when in these types of problems, then they will give you numbers to plug in for mass and volume, and you're going to solve for K algebraically. So let's do that. So if the mass, let's say, so they said the mass of 2 liters of the substance is 10 kilograms. So the mass would be 10 kilograms, and the volume is going to be 2 liters. So we would change mass to 10 kilograms. The constant is what we're solving for, and 2 liters. You see that? So let's solve for K. So I'm going to divide both sides by 2 to isolate my variable. 10 divided by 2 is 5. So my constant is 5. And so with that in mind, it goes on. See, this is a 2-part problem. They all will be 2-part problems. What will the volume of 35 kilograms of the substance? So now we go through, and if the mass was changed to 35, and we know our constant is 5, they want to know what the volume is. So they said, what will be the volume? We're solving for volume now. If we know what the constant is 5, if the mass changes to 35. So now we're changing this to 35, 5 times volume. Again, we would isolate our variable. 35 divided by 5 is 7. So our volume would be 7. Does that make sense? So we're solving for K first, and then they say, but what if, and they change one of these 2 numbers. What if that? Then you put that answer in and solve it a second way. And so let's look on your homework. For A and B, it's both on direct variables, or varies directly. And so A says the mass of a substance varies directly of the volume. The mass varies directly, K, volume, just like we did this problem. So number A on your homework is just like that with different numbers. I'm going to let you solve for that. And then B is under certain conditions, pressure of a gas varies directly with temperature. So pressure varies directly with temperature. Again, and you'll plug in the numbers for the pressure and temperature and solve for K. And then it says, but what if this? And then they tell you a different number and you're going to solve something else. And so you simply solve for your variable for both A and B. Now, C is talking about inverse variation. And so let's go to part B now. So on part B, for inverse variation, inverse, remember, it's like the upside down version. And so they're going to use a fraction in this. That's how you can remember this. So when it says it varies inversely, you know you're going to write it as a fraction. So the first example is the pressure of a perfect gas varies inversely as the volume. So that's how you know how to write the K part, the constant. So pressure varies inversely to volume. Okay? Same sort of setup. Or if it says the current varies inversely as the resistance. So you'd say the current varies inversely for the resistance. Or if it said the velocity inversely proportional to time. Same thing, it varies inversely. They use the word inversely. So velocity varies proportionally to time. So here's your K and time. So again, you set it up and then you solve for it. So let's look at this example here they give you. Under certain conditions, the pressure of a perfect gas varies inversely to the volume. I'm on example 113.4. So pressure is going to vary inversely to volume. And then it's going to give me some numbers. When the pressure of the quantity of gas is 7 pascals, the volume is 75. So if the pressure is 7, my constant is what we're solving for, my volume is 75. So we're going to solve for K. So when we solve for K, what we're going to do is we're going to multiply both sides by 75 to X that out. That's the same as 75 over 1. We can cancel that out. So K is going to equal 75 times 7, which is 525. So that's my K. Now, the second part of that problem is, what would the volume be if the pressure is increased to 15? So now my P is 15. I know what my K is. My K is 525. And it's asking me, so what is the volume? So now I'm solving for the volume. Okay? Now, to do this is a little trickier with your variable you're solving for on the bottom of the equation. It's not as easy to just isolate the variable. So we're going to have to take that in 2 steps. So to do that first, let me find my spot here. We are going to multiply both sides by V. That moves my V over here. So that would be canceling it out over here. I just needed to move it. And so now I have 15V equals 525. Now I can divide both sides by 15 to solve for V. And so V equals 525 divided by 15, which is 35 liters, and that is my volume. So for part C of your homework, it says, under certain conditions, the pressure of an ideal gas varies inversely as the volume, just like we just did. This problem is very similar to this example we did on point 4. And so I'm going to let you fill in the numbers for that. And it should be pretty simple. You just set up your equation and solve for the variable. And that's it. You just have 3 problems to do like that. And it's called direct variation and inverse variation. You can do it.